Hello, geometry students. Today we're going to talk about this definition of similarity. A loose definition is two figures, if they have the same shape but different sizes, are said to be similar. But here in geometry class, we have a more specific definition. If two shapes are similar, it means two things. There's a two-part definition. It means all their corresponding angles are congruent and the ratios of the lengths of the corresponding sides are equal, meaning the corresponding sides are in proportion. Before we go any further, I want to make sure you know a new symbol. This is our new symbol for the day. This squiggle here indicates that polygons are similar. And here's some more vocabulary you're going to need for today. An extended proportion is what we can write if we're going to show that all of the corresponding sides are in proportion. Because we know from our review of ratios and proportions that a proportion is an equation that states that two ratios are equal, and an extended proportion is when three or more ratios are equal. And so you'll have as many ratios being equal as there are sides in the similar shape. Another bit of vocabulary is similarity statement. It's analogous to the congruency statement in that we have to line up the corresponding parts, but notice instead we use the similarity symbol, meaning that the shapes are similar, not congruent. And if we have a situation where we can write or we're given a similarity statement, then the full weight of this definition comes into play, meaning all the corresponding angles are congruent and all the corresponding sides are in proportion, meaning their ratios are equal. Now notice that in every single ratio, I went from a side in the little shape to the side in the big shape. In each case, I made the comparison in the same order. So if you look at the extended proportion, you're going to see that in each one, it was little shape to big shape, little shape to big shape, little shape to big shape, little shape to big shape. As long as you're consistent, you have to be consistent in order for the extended proportion to be truthful. So I want to model how you would do it in a case like this. What would you do if you're given this similarity statement? Well, we know everything lines up, and we can also see from the scratch marks that angle A is congruent to angle X, B is congruent to Y, angle C is congruent to angle Z to qualify if all corresponding angles are congruent. Also the ratios, how will we know who to line up? Well, we could just go from the similarity statement. AB has to correspond to XY, BC corresponds to YZ, or you can go by using the scratch marks that are on the diagram. You see that this side is in between the one scratch right angle, and you see that this side is in between the one scratch right angle on its side as well. And so we now see, because of those marks being the same, 15 corresponds to 6. And we'll always reduce our fraction. 3 will go in. The next thing we can do is compare the side that goes from the right angle to the 2 scratch. And where is the right angle 2 scratch over here? It's 8. And so we see 20 corresponds to 8. Well, let's reduce that fraction. Okay, it's the same. And now finally, we can look at the side in between the 1 scratch, 2 scratch, 1 scratch, 2 scratch. And in that case, 25 will correspond to 10. And again, we can reduce that. And so we see that the second part of this definition is true. All the corresponding sides are in proportion. And we knew that this full weight of this definition would be true because we were given this similarity statement. Now, I want you to pause and on your own paper, write the answer to this problem. The first thing you can do is mark the corresponding angles as congruent. You can either write them out longhand, angle M is congruent to angle S, or you could just put the marks on the diagram, whichever you prefer. What about for the extended proportion? The extended proportion, you have to compare comparable sides. And you could find which sides correspond to one another by either looking at the marks that you've drawn when you wrote your congruent angles. You can see that the side MN is in between the 1 scratch, 2 scratch. And so over here, I have to compare it to the side in between the 1 scratch, 2 scratch. So MN corresponds to SR. Another way you could do it is look up at the similarity statement. MN has to correspond to SR. And notice that in every single comparison, I'm going from the little one to the big one. And so in every single ratio, I have to go little to big, little to big, little to big in order for the extended proportion to be correct. Okay, so now we have to see if we can use this definition of what it means to be similar and look at a situation and ask ourselves, are these shapes similar? Well, we see from the marks that all the corresponding angles are congruent. And now let's compare corresponding sides. This side in between the 2 scratch right angle corresponds to this side. And so that ratio is 2 to 1. Let's go pair of corresponding sides by pair of corresponding sides. And if they're all 2 to 1, then we've got some similar shapes. Let's look. Here is a side between 1 scratch, 2 scratch. Here is a side between 1 scratch, 2 scratch. But that is a 1 to 1 ratio. And those two things are not the same. And so we can say the sides are not in proportion. And because of that, we have to say no, the sides are not, these shapes are not similar. How about these two shapes? Pause and decide if you think these two polygons fit the definition of similarity. We see right away that all the corresponding angles are congruent. Now let's look at the sides. Here we have in between the 1 scratch, 2 scratch. So the same markings over there, we would be comparing 8 to 10. And if we reduce that, all right, how about this side in between the 2 scratch, 3 scratch? Let's compare 12 to 15. And let's reduce that. Okay, so far so good. We've got 2 pairs of corresponding sides having the same ratio. Let's see if the final ones also have the same. Let's reduce it. And since they all of the corresponding pairs of corresponding sides have the same ratio, that means they're in proportion. And so we can say, yes, these two polygons are similar. How about now? So pause and decide if you think these two shapes are similar. We can see right away that all their corresponding angles are congruent. But we have to remember that we see these are rectangles, so we know that's a special parallelogram, so we have to put in their opposite lengths so we can really go and compare all corresponding pairs of sides. But we see that since we have 2 different lengths in each shape, we're going to compare the small one to the big one. So here we've got our shortest side 5 comparing to the shortest side in the other shape. And when we look at that, we see we can reduce that fraction. And that will be the same ratio as the other 5 to the other 15. All right, let's look at 10 to 20. We see that that reduces differently, and we see that these are not the same. So we see the sides are not in proportion, and therefore the shapes are not similar. So the sides are not in proportion, therefore these polygons are not similar. Okay, how about these two shapes? We see that all corresponding angles are congruent, and since all the sides are the same, in each case, it'll be 3 to 4.5, and that reduces to a 2 to 3 ratio. So for every pair of corresponding sides, they have the same ratio, meaning all the sides are proportional. So this case, we would say, yes, the shapes are similar. And our final one, let's try this one. Pause and decide if you think these two shapes are similar. Rectangles, so we use our knowledge of rectangles, opposite sides being congruent. And then we're going to go, all the corresponding angles are congruent, but let's see about the sides. When we're comparing the sides, over here in this rectangle on the left, the shortest is 4. Over here on the right, the shortest is 3. Over here on the left, the longest is 10. Over here on the right, the longest is 8. And if we are going to reduce that, we will get something that they are not similar. We get a couple, the sides are not in proportion, so therefore the shapes are not similar. And so I will leave you with this adorable picture of a kitten and a puppy and wish you a great day.